Hello my dear students, welcome back to Learn Physics. In today's topic, we are continuing with our measurement and errors portion. In that, we were discussing the exercise questions, right? So 24th question, till 24th question we did. Today I am starting with 25th one. The radius of a cylindrical wire is measured by screw gauge is 1.25 millimeter. Length of the wire is 25 centimeter and the mass of the wire is 12 gram. Density of wire is. So children, while doing this one, please try to write down the question and try to solve by yourself. If you are doing like that, then only this video will be useful for you. Okay, simply if you are hearing the video, it won't make any difference in you. So try to write down the question, and hearing that you can write down the data and try to solve. After that you can check whether your answer is correct or not. Okay. Length of the radius of a cylindrical wire is measured by screw gauge is 1.25 millimeter. So the radius is given as 1.25 millimeter. The length of wire is 25 centimeter. Length is 25 centimeter. And the mass of the wire is 12 gram. Mass is 12 gram. So here density of the wire is, every units are in gram per centimeter cube. So we should find out the density gram per centimeter cube, because in the options it is given like gram per centimeter cube only. So here we can convert it into centimeter. 1.25 into 10 to the power minus 1 centimeter. Millimeter to centimeter conversion. So gram per centimeter cube we should get. Density, what is the formula? Mass by volume. So for the past 2-3 days we are doing the same kind of problems only. Now you can say, so density equals mass by volume. For a wire, how we will find out the volume of a wire? Pi r square L. So V equals pi r square L. So pi 3.14 into r square is 1.25 into 10 to the power minus 1 the whole square into L is 25 divided by, so this is volume. Density equals mass by volume. Therefore density equals mass is 12 divided by 22 by 7 or 3.14. Anyone you can write down. Into 1.125 the whole square into 25. Okay, while you are solving this, you will get the answer as 9.8 gram per centimeter cube. So here, if it is 9.8 gram per centimeter cube, here what is the significant? How many significant figures? 3 significant figures, 2 significant figures. Here it has 2 significant figures. So in the final answer, we should retain 2 significant figures only. So instead of calculating in the same way, you can just go through the options. Here it is 9.8 plus or minus 1, 9.8 plus or minus 0.1, like that it is given. All the true values are given as 9.8 only, and only 9.80 is given. So if the question comes like that, what you should do? You should just go through the options first, because in the option part I will write down the options also over here. 9.8 plus or minus 1 gram per centimeter cube. Next 9.8 plus or minus 0.1 gram per centimeter cube. Then next is 9.8 plus or minus 1.01267 gram per centimeter cube. 9.80 plus or minus 0.01 gram per centimeter cube. So in those cases and all, first you can, while getting the numerical itself, you can just check the true value part. See, that is here everywhere it is 9.8. Here alone it is 3 significant figures are given. So this one we can omit that. So that one anyway it won't be coming. So we can check only these things, these 3. Okay, in that itself, here we know this one won't be coming, because so many number of significant figures won't be coming, either this one or this one. That one you should find out. So how we can find out the density? Change in density, delta rho relative density will be equal to change in volume, change in mass divided by delta m by m plus delta V by V. Okay, so delta M by M is, how we will find out? Delta M is 1. 12 gram only it is given, right? So it is 1 divided by mass is 12. See here, delta V by V. How we will get? 2 into delta R by R plus 2 delta L by L. So here 1 by 12 plus 2 into delta R is 0.01. 0.01 divided by 1.25 plus delta L. Delta L is again 1 divided by 25. And you can find out delta rho as 1 by 12 into rho. The whole into rho. This will give you delta rho. Delta rho, while you are calculating this one, you will get the value as 1, you will get gram per centimeter cube. So here you will be getting it as 9.8 plus or minus 1. Okay, 1 gram per centimeter cube. Option A is the answer. How we will conclude to that 1? Because it is 1 by 12. Here 0.01 into 1.5. This here it is 0.1. Actually it is 25.0 is given. So its option is 20.1 divided by 25. So here we will be getting the answer like 1 centimeter cube. 1 gram per centimeter cube. The final answer is 9.8 plus or minus 1 gram per centimeter cube. So don't wait for don't try to calculate all the questions, all the things. Instead of that, what can you do? You can just eliminate the wrong ones. Try to eliminate the wrong ones and try to find out the final answer. Next one. The length of a simple pendulum is about 100 centimeter, known to have an accuracy of 1 millimeter. Its period of oscillation is 2 seconds, determined by measuring the time for 100 oscillations using a clock of 0.1 second resolution. What is the accuracy in the determined value of G? So what and all data are given, that we will write down. So hearing this question, please try to solve the answer. Okay, the options I'll give you: 0.2%, 0.5%, 0.1%, 2%. So here length of a simple pendulum is about 100 centimeter, known to have an accuracy of 1 millimeter. That means length is 100 centimeter. Its accuracy is 1 millimeter. So we can write it as delta L equals 1 millimeter. Okay, then its period of oscillation is set 2 seconds. Determined by measuring the time for 100 oscillations of a clock of 0.1 second resolution. So resolution is given like 0.1. As its period of oscillation is 2 seconds, determined by measuring the time for 100 oscillations using a clock of 0.1 second resolution. So resolution is given like 0.1. Okay, then what is the accuracy in determined value of G? G value accuracy we need to find out. So including all these things, which formula we know? Time period T equals 2 pi into root of L by G. In that 2 pi is constant, right? So we don't want that one. While we are considering the answers, every answer's options are given in percentage. So we can calculate the percentage error. That is the accuracy in G. So for that we require a formula for G. T square equals L square. T square is proportional to L by G. That is G equals, or we can write it as 4 pi square into L by T square. What will be the percentage error in G? Delta G by G will be equal to delta L by L plus 2 into delta T by T. Write everything into 100 we need to do. That is percentage error. Into 100, into 100, into 100. Okay, so first we need to find out what is delta L by L. Delta L we already got it as 1 millimeter divided by 100 centimeter. Therefore 0.1 centimeter divided by 100 into 100 plus 2 into, what is delta T? Change in delta T is 0.1 second resolution. Period of oscillation is given as 2 seconds. Okay, period. So what will be the total time? It is 100 oscillations we took. The time needed for one oscillation is given as 2 seconds. So what will be the time required for 100 oscillations? 2 into 100. Right? Into 100. So here while we are calculating, we will get it as 0.1 plus 2 into 2 and 2 will get cancelled. This also will get cancelled. You will get it as, so here it is 0.2 percentage. So the final answer we are getting it as 0.2 percentage. It is A. Option A, 0.2 percentage. Next, the least count of a stopwatch is 0.2 seconds. The time of 20 oscillations of the pendulum is measured to be 25 seconds. Percentage error in time period. Same way we can calculate. I'll do it over here only. Least count of is given like 0.2 seconds of time period. Then next is given time of 20 oscillation of a pendulum is measured to be 25 seconds. For 20 oscillations, time required for 20 oscillation is 25 seconds. Okay, so what will be the error in this calculation? Delta T divided by T into 100. What will be the time? What will be the error in this much of calculation? The same thing only will be the error which is coming for the period of oscillation also, right? So delta T by T into 100, that is 0.2 divided by T is 25 into 100. So here we will get it as 0.8 percentage. This will be the percentage error, because otherwise we are just dividing with a number, right? So that is not relevant there. So here no need to calculate the period. If you are again calculating the period, this will go wrong. Okay, so no need to calculate that. Just take the time. Using stop clock, we are finding out the time. It's not the time period. Right? Time only we are measuring. So error will be there for time only, not for the time period. Okay, so while you are finding out the percentage error, you need to find out the percentage error in the time. Clear? Next, I am going to explain to you about assertion reason type questions. How to do assertion reason. So assertion, one sentence will be given, and reason, one sentence will be given. What you should do is first read assertion and reason. Both the things, assertion whether it is correct or not, that sentence whether it is correct or not, reason, that sentence also correct or not. You should find out. If assertion is true, see, options will be, first you should be familiarized with the options. Assertion, reason type questions, 5 options can come. First one, so here in this, if both assertion and reason are true and reason is the correct explanation of assertion. Okay, so both assertion and reason are true. Both the sentences are true if and reason is the correct explanation for assertion. And next option will be reason and assertion. Both will be true, but reason is not the correct explanation for the assertion. And next option will be C. That is, if the assertion is true, but reason is wrong. Then assertion is false, reason is true. And if both assertion and reason are false, these are the options which can come for the exams in the assertion reason type. So you can check. So the options will be both assertion and reason are true. Reason is not the correct explanation. This will be the first option. Then second is, first one is the correct explanation, it can come, or assertion and reason are true. Reason is not the correct explanation. And third one which can come is assertion is true, reason is false. And D1, assertion is false and reason is true. E part, assertion and reason are false. So you can, while you are getting this kind of question, first you can check whether you can read the sentence assertion, whether it's true or false, you should identify. Okay, if it is, suppose if assertion is true, you can go for reason, true or false, that also you can identify. If assertion is true, then here assertion and reason are true, assertion and reason are true, this answer will be in any one of these, A, B, C. Okay, this one won't be coming because assertion is false, assertion and reason are false. So these two options won't be coming. No need to choose that one. So suppose reason is true, assertion is false. Then you can go for reason is true and assertion is false. These three options. Okay. Now, after finding out whether it is true or false, you can go for the assertion and write down a because over there. After assertion, because you can write down and then read the reason. Then you can identify whether as a reason is the correct explanation for assertion or not. This is how you should do the assertion reason type question. First eliminate the wrong ones and then go for the reason whether it is correct or not. That one you can check. Clear? Now here first question, assertion. Out of the two measurements L equals 0.7 meter, L equals 0.70 meter. The second one is more accurate. More accurate. This is the assertion. Next, reason is given like in every measurement, mostly the last digit is not accurately known. Okay, last digit is not accurate. Okay, so here which is L equals 0.7 meter, L equals 0.70 meter. This is more accurate, it is given. It's correct only, right? Here there's two significant figures are there, so it is more accurate. Last digit is not accurate. Not accuracy won't be there for the last digit. So that also true. So assertion and reason both are true. Now we should write down. See, because. See, 0.70 meter more accurate because last digit is not accurate. Is it coming correct? No. But assertion and reason are true. A and R are true. But reason is not the correct explanation for assertion. Okay, here we will get the answer as B. Okay, children. So the answer is, this is how we should verify this, we should find out the assertion reason questions. Second one, assertion. The watches having hour hand, minute hand and seconds hand have least count as 1 second. Reason. Least count is the maximum measurement that can be measured accurately by an instrument. So assertion, watches hour hand, minute hand, second hand. Everything has a least count of 1 second. Is it correct? No. With hour hand, we can measure minimum 1 hour, right? But here in the second case, in second alone, we will be getting 1 second as least count. So that is not true. Next, least count is the maximum measurement that can be measured accurately by an instrument. So least count is the minimum measurement that we can measure using the using an instrument. Here reason is least count is the maximum measurement that can be measured accurately by an instrument. Maximum we can measure that many numbers, that is that many numbers we can measure accurately. So another definition for least count only it's given over here, right? So here reason is true, but assertion statement is wrong. So here the answer will be assertion is false, reason is true. Okay, clear? So this is how we will be finding out the answers. So here I'll give you 2 more questions for doing the same thing. Subjective questions only. It is not multiple choice questions. So subjective questions, 2 more questions I'll give. Please try to do that. Okay, so I think today's class also useful for you, and if you have any suggestions, please give it in the comment box. And if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.